All right, hey gang, happy Thursday. Today's lesson is on section 1.6, properties of numbers. All right, now this is really just facts about how numbers work and how operations work, especially when it comes to addition and multiplication. But try to remember right off the bat that subtraction is basically addition. So addition and subtraction kind of go hand in hand. And multiplication and division are essentially the same also. At least when it comes to especially when it comes to things like just flat out properties of numbers. We don't need to talk about subtraction if we're talking about addition, and then same with division and multiplication. Um, so again, as always, just kind of write down what I write down because you'll be turning in just your notes. And I think the last thing I'll say before just kind of blasting right through this is that I'm going to assume or whatever that most of you, if not all of you, are going to just like understand these just naturally, like because these are just like very simple facts about numbers and operations, and they are official properties that are worth writing down like in a textbook or in your notes, but I mean they are like basically pretty simple and pretty like fundamental. So here we go. First is what's called the commutative property of addition. In a textbook, that would look like this. Okay, if you'd have like A plus B, that's the same as B plus A. In other words, it doesn't matter when you add, it doesn't matter what number you say first. You could say, 3 plus 5, that's the same as 5 plus 3. You get the same answer. It doesn't matter which number you say first. They're equivalent. This property also applies to multiplication. If you have A times B, like some number times whatever some other number, and again, you could use equal signs. I think in textbooks they use equal signs a lot. But I mean, like the point is like they're the same, B times A is interchangeable. It's the same as A times B. They're equal. I could have used an equal sign here. Because you understand that 4 times 6 is exactly the same as 6 times 4. So again, the word commutative in these math properties just means like when you're adding or subtracting, or subtracting, but when you're adding or multiplying, it doesn't matter what number you say first. You could or what order the two numbers are in. Then there's the associative property of addition. Maybe you remember this. This just means that if you have this, if you're adding three things, adding these two together first, or adding A and B first and then adding in C, or adding the B plus the C first, it doesn't matter. So again, like this overall, this property just means when you're adding three numbers together, it doesn't matter which two you add first. You could add these two first, you could add these two first. It doesn't matter when you're adding. So like for example, if you were doing 1 plus 5 plus 7, you could add the 1 and the 5 first, or you could add the 5 and the 7 first, put parentheses around that. Doesn't matter, that's associative, and that also applies to multiplication. When you're multiplying and you're working with like three numbers, it doesn't matter which two you multiply first. So I don't know, like 4 times 3 times 8, let's just say. You're going to get the same answer. So again, like equal signs are just, you could they're the same basically. They're equal, because it doesn't matter which two numbers you multiply first or when you're adding first. All right, next we have like this identity property of addition. So the word identity, think about like maintaining your identity, or like identity theft. Like if you've ever seen The Office, where identity theft is not a joke, Jim. Millions of families suffer every year. But no, identity, it's a pretty good name for this property because you don't want to like lose your identity. So think about this, the identity property of addition. Think about it, peoples. What would you add to a number so that the number does not lose its identity? Think about it. A plus what? Like any number A, whatever, whether it's 5 or 25 or 87, whatever. 99.2. What would you add to a number so it doesn't lose its identity? Well, 0, of course. Like 89.2 plus 0 is going to stay 89.2. How about the identity property of multiplication? Some number times what will not have it lose its identity? What would you multiply to some number? Like 5. 5 times what would not have it lose its identity? 1. If you multiply by 1, it keeps its identity. All right, here next is like the inverse property of addition. Do you remember kind of writing down in earlier notes about like an additive inverse? So the inverse property of addition, okay, that goes like this. It says that if you take a number and its additive inverse, in other words, like opposite, okay, you're always going to get 0. I mean, that's, again, it's one of those like no duh kind of things. Like, well, duh. If you add like 7 plus negative 7, or 9 plus negative 9, okay, you're always going to get 0. It's just a fact. But that's the actual property. We're just going to put it down in black and white in purple. A plus negative A is always going to equal 0, because they're additive inverses, they're opposites. There's also an inverse property of multiplication. Has this stupid thing been up here the whole time? Ugh. I apologize. Anyway, there's also, as I was saying, there's also an inverse property of multiplication. Do you remember like the whole like multiplicative inverse? What was the better name I liked better? Rather to say, instead of saying like a multiplicative inverse, what's the word that I like better and probably is just like simpler to use overall? Reciprocal, or as I say, refliprical. So if you take a number and you multiply it by its reciprocal, so if you do like A times 1 over A, these are basically reciprocals, what are you always going to get? What happens when you multiply a number, any number, times its reciprocal? Well, the property and the fact of the matter is that you're always going to get 1. It's just a fact. So examples like 8 times 1 over 8, because 8 and 1 over 8 are reciprocals, you're always going to get an answer of 1. Another pretty good example worth writing down is like 3/5 times, well, what's the multiplicative inverse or reciprocal? What's the reciprocal of 3 over 5? Well, you just flip it. Refliprical is what I call it. And again, you're always just going to get 1. So again, you multiply a number. So that's the inverse property. You add a number and its opposite, you're always going to get 0. You multiply a number and its reciprocal, you're always going to get 1. Final stretch. the symmetric, you think about how like symmetry, how symmetry works. The symmetric property says that if you can say B equals A, that means you can also say B equals A. Again, like it doesn't matter. They're saying the same thing. That's what the symmetric property actually is. Like saying A equals B is the same as saying, B equals A. So as an example, if you can say that like some, X equals 2, you could also say 2 equals X. Doesn't matter which, when you have like an equality like that, like an equal sign, right? Two things that are equal. Doesn't matter which number you put on the left and which number you put on the right. Or I suppose you could, another example would be like 10 equals 7 plus 3. To say the same thing, this is saying the same thing. 7 plus 3 equals 10. They're symmetric. Like think about like how your face is like genetically symmetric in general. You know what I mean? Or things that are symmetrical. The left side equals the right side. Like that's symmetry. Like you could draw a line down the middle and have the left side just basically equal the right side. It doesn't matter. They're the same. Anyway, the distributive property, I'm thinking you guys know this. When you have like some number out here and it's being multiplied to this quantity of like B plus C, you can multiply the A to both the B and the C, and it equals A times B plus A times C. The A is being multiplied to the B and the C kind of like at the same time because it's outside these parentheses. So just kind of like an example, 5 times 2 plus 4, that would equal 5 times 2, 5 times the 2, plus 5 times the 4. So basically 10 plus 20. Or you could have like a 3 out here, and then like an x plus 1 in here. To multiply the 3 to this sum, you'd multiply 3 to the x, and then you'd also multiply 3 to the 1. So you'd get 3x plus 3. Because 3 times x is just 3x. You can't really even simplify that. It's just 3 times x. And then 3 times 1 is 3. All right, really the final stretch. The multiplicative property of 0. I mean, these titles are all like pretty, clear. Like they're pretty good descriptive titles here. Multiplicative, so we're going to be talking about multiplication. Property of 0, we're going to be involving 0. So what that means is this. When you take any number you can imagine and you multiply that number, it doesn't matter whether it's like 3 times 0 or negative 6 times 0, any number times 0, you are always going to get, you said it, you know it, 0. So 3 times 0 is 0, and negative 6 times 0 is 0. Again, pretty much all these properties, if not all these properties, you're thinking like, well, no, duh, I knew that. Like, that's how numbers work. That's how adding and multiplying works with certain numbers, especially. Like the multiplicative property of negative 1, right? If you take any number, and we'll just keep using the variable a, we could use x, we could use m, we could use alpha from the Greek alphabet. But anyway, any number a times negative 1, what are you always going to get? Like if you have like, 9 times negative 1, or if you have like negative 12 times negative 1, what happens when you multiply any number times negative 1? Well, you get it's opposite. You get negative of whatever A was. So 9 times negative 1, you end up with negative 9. Negative 12 times negative 1, you end up with like negative 12, which is positive 12. So there's also, because what you're about to do a crossword puzzle as like classwork. So it's another good opportunity to build up your classwork grade. Remember, there's 3 different categories of grades. There's homework, there's a classwork grade, like your notes. So here's something worth saying out loud here in this video. All of your notes are classwork grades. And classwork is weighted a little bit more than homework, if you didn't realize that already from like your syllabus. Hello, syllabus. And then like tests are weighted more than both of those, so tests are weighted the most, like quizzes and tests. Anything that would go in like the test category. Most quizzes are going to go in the test category, if not all of them. And classwork and homework, like kind of in that order of importance. Like it's all important. Now, what you're about to do is like a crossword today, which is like a classwork grade. But there's also a 1.6 homework assignment, which would go in like your homework grade. So both of those are going to be assigned, for like the next couple of days or whatever. And I feel like throwing in like one more property just in case I threw it on the crossword. I don't know. There's actually this property called the reflexive property. And all that really means is that any number equals itself, like a mirror that you see reflection, reflexive. So like A looks in the mirror and it sees itself, like any number equals itself. Like, 7 equals 7. And that's what it can be called the reflexive property. So that's like if I was going to add one more property to this list, it would be the reflexive property. So you have a crossword. The crossword speaks for itself. But really quick about the homework that you'll do also eventually over the next day or two. I added all these shorthand code words to save yourself some writing. So name the property that's in play here. You can just kind of give me the code instead of like writing out. Like if you thought it was the commutative property of multiplication, which it's not. This is not like number 1 here is not the commutative property of multiplication. But if you thought it was, you don't have to write all this out. You can just write CPM. Okay, so use these codes up here to your advantage. Simplify each expression. A lot of these are going to involve the properties, whether you realize it or not. Little word problem. Same thing here. Like what property am I invoking in this step? Like going from here to here, exactly what property. And you can use the codes. If you want to keep using the codes, that's fine. But like give a reason, like give a pretty good reason whether it's a property or whether you're just adding something together. You know what I mean? Like, spoiler alert, going from this line of work to this line of work, that's just multiplying. You can just say, I multiplied. That's all I really did. That can be a reason. And then simplifying, again, you're utilizing, whether you realize it or not, you're utilizing a lot of these basic fundamental properties. Anyway, that's it for 1.6, just all those properties that hopefully you can understand. And anyway, I'll see you on the next live Google Meet. See ya.